Hey guys, so this is our lesson video on experimental design. So we talked a little bit about experiments in class where we looked at kind of the difference between observational studies and experiments, and then just a couple of notes on what we're allowed to conclude or generalize with each type. So today we are going to kind of go a little bit deeper and talk about experiments in particular and how they're different. So our objectives today are define and apply what we call the principles or rules, I guess, of experimental design. And then we're going to differentiate between forms of control in an experiment and ways that we can better control our experiment. So the big picture is in statistics or with experiments. We move this around. Our end goal of an experiment is to collect evidence for a cause and effect relationship between the explanatory variable and the response variable. So the explanatory variable would be the thing that we're changing, the treatments that we're giving, and then the response variable would be what we're measuring at the end of an experiment to see whether our treatments made any difference. Right. In order to accomplish that, we have to follow three basic principles that we call the principles of experimental design. So these are things that make experiments better and give us kind of a really good, solid cause and effect relationship. So the first principle of experimental design is randomization. So randomization basically means the use of chance to assign subjects or units, experimental units, to their treatment. So randomly assigning the subjects to the treatments as opposed to just letting them choose their treatments, which would actually be just an observational study. Okay, so why is randomization important? Okay, so randomization, in theory, equalizes all other variables. So if there are other variables, like lurking variables, that could impact the response variable, by randomly assigning our subjects to their treatments, we're kind of spreading out all aspects of that variable or all those other variables that could be affecting things, so that in theory they kind of don't matter as much anymore. It basically gives us treatment groups that are more or less the same in terms of any other factor or variable that we think might have a difference. So that is why randomization is important. Our second principle of experimental design is replication, which means kind of a couple things. It means using multiple subjects in each treatment group. So you should have an experiment that has more than one subject doing each treatment. And then, if possible, repeating the experiment multiple times with different subjects or at different times of the day or different times of the year or in different places, just kind of repeating it to see if we get the same results multiple times. AP exam tends to refer to replication as using multiple subjects in each treatment group and not just doing with one person. So why is replication important? So in theory, replication makes sure that the results we get aren't a fluke. So if we just get them with one person in each treatment group, the results we see could have been completely a fluke. And also, even in an experiment that we do once with multiple groups of people, that one time with that one group of people, it could have been just it happened that way randomly. Whereas if we repeat the experiment multiple times and get the same results, we're kind of more confident with those results. Basically, it also gives us a more precise estimate for the response variable within each treatment group. So the more people, the more subjects we have within each treatment group, the better idea we have of what is the true response variable, or what does the data actually look like for each of those treatment groups. It gives us good data. Our third principle of experimental design is control. And control is basically just the overarching word that means we're going to make conditions similar as possible for all of our treatment groups, aside from the actual treatments. So we're making the treatment groups as similar as possible for all treatment groups. So that could just be that we. Sorry, I keep losing my train of thought. We kind of set out rules. So if we're testing a medication, we might tell them, don't take any other medication. Don't do any kind of treatment that might affect your response or the way you react to this particular medication. We're just kind of setting rules in place so that things are as similar as possible. But there are other ways that we can specifically control. So why is control important? So in theory, I keep moving myself around to be out of the way. In theory, control minimizes the effects of other variables on our response variable because we're controlling it. We're kind of putting it in place to where those other things aren't having an effect. And then if we observe a difference between our groups, so if I observe a difference between our treatment groups, I want to be able to say it's because of the treatment and not because of something else. So the more that we're controlling that something else, the more confidence we have in the actual treatments. So that is the thought. Right? So a couple of things to make note of in terms of all of these words. So one word we have when we talk about experiments is confounding or confounding variables. So two variables are considered to be confounded when they both have an association with the response variable. So basically we have this other variable that's not something that we actually put into our experiment, and it's also having an effect on the response variable, and we can't tell whether the difference we're seeing between our treatment groups is because of the actual thing we changed, our explanatory variable, our treatments, or if it's this other thing that's also in there. So we also sometimes use the word lurking variable. I talked about lurking variables when we did the lesson in class, but lurking variable is kind of a similar concept to confounding variables. They both mean there's something else happening. There's some other variable that is connected to my explanatory variable maybe, but it's also having an effect on our response variable. And we can't really tell how much of an effect it's having, and we can't decide or tell whether the difference we're seeing in our treatments is because of the treatments or if it's because of this other confounding variable. So a quick way to differentiate between the confounding and lurking. Confounding is usually what we use when we're talking about experiments, and then lurking is usually what we use when we're talking about observational studies. But you will never be expected on an AP exam to differentiate between the two. Just know that they kind of mean the same thing. There's something else going on. There's some other variable that's affecting things, and we can't necessarily rely on our treatments. Okay. So randomly assigning, this is another big picture thing, randomly assigning treatments helps to minimize the effects of confounding variables. Because again, we are in theory, spreading out those other variables amongst my treatment groups so that we have treatment groups that are similar in a lot of aspects. But if we do have a specific variable that we know of and are concerned about, so if gender is something that we feel like will affect the response, if age, how old someone is something we know or believe that will affect our response, there are ways for us to deal with that specific variable and control for that specific variable a little bit more. That is something we'll talk more about in the next lesson. So an example of a study on stomach ulcers, this is from real life. In 1958, an initial experiment for a very creative treatment for stomach ulcers involved anesthetizing the patient, knocking him out, putting a balloon in the patient's stomach, and then filling the balloon with freezing coolant. So they put a balloon in the patient's stomach with this freezing liquid and left it in there. And in the initial experiment, there were 24 patients and all were cured of their stomach ulcers. So for a while, this treatment became very popular, even more so than surgery. It was kind of the go-to treatment. It was the popular treatment of the time because of this one study. But there were some skeptics. So what is wrong with this experiment? So just think for a minute, what could be wrong with this experiment that made the skeptics kind of question things? So a couple big things is, this experiment wasn't actually an experiment. So they had one group of patients who all had one treatment. There was no control group, there was no second treatment that they were testing against. So it's really hard to tell for them whether that treatment actually did anything or meant anything. It was just one group. And then secondly, they only did this one time. There was no replication in terms of repeating the experiment multiple times. So those are a couple of things that you might have said. You may have said other things as well. But that's a big thing. So control group is a word I mentioned. I didn't mean to mention it early. I spoiled myself. But control group is basically a group that is used to compare our experimental variable, explanatory variable against. So This could be like a previous version of a treatment or no treatment at all or something like that. So with the placebo, I'm sorry, I keep spoiling future stuff. For the gastric freezing treatment for ulcers, a proper experiment would have one group of subjects getting the gastric freezing treatment and one group of subjects maybe getting surgery or having no treatment, like their ulcers just aren't treated at all, just some other group to have something to compare against. That's really important in statistics. We have to have something to compare against. So if you only have one thing you're testing, you need to have at least one other group called the control group that are doing like an old treatment or no treatment or something like that. All right, so moving on. So they did a new experiment 5 years later where they had a controlled experiment with a control group where they put 160 ulcer patients divided into two groups. 82 received the gastric freezing treatment, where in that group, 34% of them improved. So already we're talking like even just repeating the experiment did a good thing, because in that first experiment, the 24 patients, all of them improved. And now with the second, just one repetition, one replication of the experiment, we're already seeing a drop in improvement rate. But then in the other group, 78 received a placebo treatment, and 38% of them improved. So gastric freezing was no better than a placebo treatment, right? Our gastric freezing group, the actual treatment that we thought was amazing, didn't do any better than a placebo treatment. So you might be asking yourself, you may have known, you may have heard this word before, but what is a placebo? So a placebo is basically a fake treatment that has no actual physical effect on the response variable. So we use it a lot in medical studies and medical experiments where you have a control group, but instead of just giving them maybe an old treatment or a like no treatment, you give them a fake treatment. So this works really well with things that are like pills that you take or maybe even shots that you're given, because it's really easy to create a fake version of that looks and feels really similar to the real version of the treatment. Right? There is such a thing as placebo effect, though. So if you've ever heard that term, the placebo effect basically just refers to the phenomenon where we see a change in the response variable with any treatment that we give. So people who get a placebo pill, like a sugar pill, as a treatment, they feel better. And it's unexplainable. It's just something that happens in our brains. You get any kind of treatment and all of a sudden you feel better because you're getting something. So even when a subject is not getting like the real medicine or the real treatment, they think they're getting better. They think they are getting the real treatment, so they feel like they're getting better. Maybe they are getting better, and somehow that's enough, right? But the idea is that we want our real treatment to work better than a fake treatment. So if our real treatment is working just as good or even worse than a fake treatment, then our real treatment's not very good. So placebo effect is something that happens when we use placebos, but it doesn't invalidate an experiment. It's still useful information to have. Right? Another thing that we could have in experiments often comes along with placebos, but even when we're testing two treatments, like two medicines against each other, we might want to include something of this nature. So in blinding, subjects do not know which treatment they're getting. So subjects don't know whether they're getting the real medicine or the placebo pill, or maybe they don't know whether they're getting medicine A or medicine B. So they have no idea which treatment they got. So that's possible in situations where we can make the treatments look and feel and experience them exactly the same way. We also have something called double blind, and double blind just means that the subjects don't know which treatment they're getting, but also anybody who we would call like an evaluator also doesn't know. So that could be a doctor, a nurse, anybody who comes into contact with the subject during the course of the experiment could be an evaluator. And if the evaluator or evaluators don't know which subject or which treatment each subject received, as well as the subjects, that's called double blind. Double blind is not always possible. but it is a good way to kind of control things. And the reason that would matter, right? The reason either of these would matter, the subject knows they're getting the real medicine, or they know they're getting medicine A, they might have a bias against that particular kind of medicine, or if they know they're getting a placebo, they're obviously probably not going to feel any better because they know what they're getting. So keeping them from knowing kind of helps to control some of those outside variables. And then the same thing with the doctor. If a doctor knows that a patient is getting a placebo, a fake pill, and the patient says, "Oh, I'm feeling much better," the doctor is going to be like, "No, you aren't, because you got a fake treatment." So that might influence how they evaluate or how they kind of look after the patient. So that also adds another layer of control. Again, it's not always possible to blind or even double blind. Another thing that comes up, some experiments, it may not be possible to blind the subject due to the nature of the treatment. Like, it's not possible to keep them from knowing which treatment they have. And you'll kind of see what I mean a little bit later. But we may be able to blind the evaluator. So we could still have a blinded experiment on the side of the evaluator, just not with the subject. So that is possible as well. And any blinding that we do is really helpful because it helps to control some extra outside variables. I kind of included a little piece here at the bottom that just says the evaluator is anybody who checks the subject for improvement, anybody who administers the treatment or cares for the subject during the experiment, anybody who has direct contact with the subject. I always get the question here like, well, if it's double blind, who knows what's going on? There's always somebody who knows which subject who's getting which treatment. But they're the only ones who know, right? So the people who are giving the medicine or the people themselves aren't going to know. So somebody knows, I promise. Okay. So last little bit, some things to think about. Let's say a pharmaceutical company is testing a new headache medicine pill and wishes to test it again in an experimental study against a control group. So in that case, we're testing a new headache medicine pill and we're testing it again against a control group who's probably getting like a placebo. Would it be possible for the experiment to be blinded? Would it be possible for the experiment to be double blinded? So the answer here is yes, as long as we make the pills look exactly the same. You take them the same way. They're both pills. We wouldn't want one to be a pill and one to be like a shot or something. But yeah, it's definitely possible. And then as long as we don't tell the evaluators which subject got which treatment, it's completely possible to do that. Not a big deal. However, if we had an experiment, I may have given that away. A cutting-edge treatment for fighting brain tumors involves drilling tiny holes in the patient's skull and injecting a drug cocktail into the brain. So, is it possible for this experiment to be blinded or double-blinded? Right? So blinding, that means the control group who's getting like maybe a fake treatment or no treatment would not be able to know which treatment they're getting. So is it possible? I guess you could like drill a tiny hole into a patient's head and then just not put anything in there. But is it ethical? Questions. It's kind of a iffy subject. It could be maybe blinded on the side of the evaluator. So whoever is coming in to kind of check in on how the patient's doing, they could maybe not be told which treatment the subject got. But in terms of double blinded on the side of the subject, I don't think that this could be blinded ethically. So those are things that we have to think about too. Right? So that is it for this lesson, and we will continue talking about experiments next time.